All right, Wizards, a little bit of review of what we did today in class. Talked a little bit about alpha level. And so just remember on these questions here, so for example, on number 13, our null hypothesis was obviously rejected in question 13 because they thought that the new scanner was significantly better than the current scanner. So my null hypothesis would be that new is the same as the current, and my alternate would be the new is greater than the current. So those are my hypotheses. And so in order for me to reject the null hypothesis, my p hat had to have occurred over there in the tail somewhere. So I will make the same decision at a 10% alpha level, but I may or may not make it at a 1% alpha level. Likewise, on 14, my null hypothesis is that there is no change in the mortality rates, where my alternate is that there is a change in the mortality rates. And I failed to reject. I did not reject HO. So my p-value, or my p-hat, must have been out there somewhere. So I would make the same decision at the alpha equals 0.01, but I may not make the same decision at the 10% alpha level. So that was one of the things we talked about today. We also talked about p-values today. And so all of these are false, and 3 and B, C, and D are false. And the big thing about p-values, I think the big thing about p-values, let me turn this over, all right? So a p-value is evidence against the null hypothesis. When my p-value is small, my evidence is strong. When my p-value is large, my evidence is weak. So in terms of these questions over here on this side, again, a low p-value provides evidence for rejecting HO, but it doesn't necessarily mean that HO is false. And a high p-value shows that the data is consistent with HO, but it doesn't mean that HO is true. So again, a p-value is just all about evidence. Either I have strong evidence or I have weak evidence. Of course, you should be able to identify the one-sided tests and two-sided tests. If you want to pause the video and read those, you can see which ones are two tails and one tails and whether they are upper or lower. Finding the p-values. Again, the mistakes that people were making today in class, we were identifying the hypotheses to OK, but again, in a hypothesis test, I put my faith and trust in my null proportion. So I use the null proportion to build my model. And there was a question about where that number came from. That is 1 minus 0.05. And this is a one-tail test because it's strictly greater than. So I'm looking at the upper tail. Another thing that people were having trouble with is they get this number on their calculator. That turns out as something as an e to the negative 10th. So that's scientific notation, which means it is super, super small. So essentially on this question, my p-value is essentially equal to 0. We didn't make any decisions. We just practiced doing p-values. And again, this kind of goes along with a video that I placed up there over the weekend, a two-tailed test. So my null hypothesis is the population proportion is 0.31, and the alternate is that it's not equal to 0.31. They're just evidence. Is this evidence of a change? That's all they're asking for, evidence of a change. So again, I use my null proportion to build my normal model. Now to do a two-tailed test, that's the null proportion. Here is my sample p-hat proportion. So I find the area in the upper tail to the right of p-hat, but I also want to be as equally far away in the lower tail. That's why it's a two-tail test. So I could be greater than it in the positive direction or equally far away in the negative direction. and both of those numbers go together to make my p-value. Both of those numbers go together to make my p-value. I add them together, my p-value is 0.0455, which is smaller than a 5% alpha level, but not unreasonably small. And then the other question we talked about today is type 1 and type 2 errors. I had a video about that over the weekend. Just remember, there are two decisions you're going to make. You will either reject the null hypothesis, or you will fail to reject the null hypothesis. And in those cases, it's possible, when you reject, it's possible that you committed a type 1 error. Not that you did, but it's certainly possible that you committed a type 1 error. If you fail to reject, it's possible that you committed a type 2 error. So type 1 errors go along with rejecting the null hypothesis. Type 2 errors go along with failing to reject the null hypothesis. I think a common example of a type 1 error is a fire alarm. A lot of you seniors will go off to college next year. Dorms at night, the fire alarms go off. You leave the dorm in the middle of the night. The alarm is going off, is saying there's a fire, but actually there's not. That's a false alarm. Another thing for type 2 error would be your spam filter. The null hypothesis is that any mail you get via email is good, not spam. So it comes to your inbox. When you get spam into your inbox, that email was mistaken for good email when actually it was spam. That would be a type 2 error. So again, you can read over these questions as well. This will be a part of your unit tests on Friday, kids. So hey, I hope this video has been helpful.